Hi, I'm Rachel and this is Chloe and Sophie, and today we will be showing you how sodium chloride, when added to water, conducts electricity. The ions in the ionic solids are held firmly in position and are not free to move, therefore ionic solids do not conduct electricity. However, if the solid is melted or if it dissolves in water, even if only slightly, it becomes an electrical conductor as the ions are free to move and can conduct the electricity.
Many ionic solids dissolve in polar solvents. The most effective polar solvent for dissolving ionic compounds is water. This is why we are using it today, I suppose, to dissolve the sodium chloride salt. Dissolving occurs when small numbers of polar water molecules align themselves with positive and negative ions. In this case, sodium is a positive ion and chloride is a negative ion, and it pulls them out of their crystal lattice.
Okay. Water by itself doesn't conduct electricity in solid or liquid state, as it is a molecular solid, meaning that it is composed of neutral particles held together by weak forces.
So the light's not.
Yeah.
As you can see.
Yeah. The van der Waals are easy to overcome. Those are the forces that hold different molecules together, but the forces within each molecule is quite strong.
Here, this is the anode, and it's the positive electrode, and in this experiment the electrons will be leaving at the anode.
And the cathode is the negative electrode, and electrons will be entering at this cathode. So,
Here we have salt and water.
Should I put some more in?
I think it's got enough.
Just go crazy.
Okay, so when we put this salt and this sodium chloride in this solution, I made an electrolyte, which is a liquid that contains cations and ions. Cations are the positive ions, which in this case are the Na ions, the sodium ions, and the anions are the negative ions, which in this experiment are the chloride ions.
Then, when we turn the battery on, the bulb will light up. Lights up. This is because the current is being carried by the ions in sodium chloride, the salt in the solution.
In this experiment, the chloride ions collect at anode, and so this one, and are oxidized to chloride gas. This occurs as the negative ions give up their charge by losing electrons, and then the electrons go through the circuit.
Also, sodium ions collect at the cathode and are reduced to sodium metal. This is reduction occurring at the cathode. Positive ions give up their charge by gaining electrons from the electrical current from the battery pack.
Yeah.
Okay. Good afternoon, ladies and gentlemen. Today we'll demonstrate the electrical conductivity of ionic compounds in a water solution. A power pack will supply the electrical current which will pass through the circuit, and if the water is conductive, the lamp should light up. This is our method of choice for the experiment, so let's give it a try. Yeah, we got that. You got to put it in the water. My lovely assistant here, Trotman, will be putting this in the water. As you can see, the lamp isn't lighting up, so the charge of electricity doesn't pass through the beaker of water, which indicates water is a non-conductor of electricity. Okay, to make things more interesting, let's add some sodium chloride to the solution and see what happens. No. Gonna give it a mix, Cameron?
Come on, Cameron. Not enough.
That'll do. Okay, and put them back in.
Didn't even stir it.
We don't need to stir it. Oh, beautiful. Wow, this time the lamp actually lit up. Well, that indicates that the sodium chloride is a conductor of electricity, whilst pure water is not. How can this be? Water consists of an oxygen atom covalently bonded to two hydrogen atoms. It is a covalent compound and is a non-conductor of electricity because there are no free electrons roaming around to carry the charge. Sodium Chloride, however, is an ionic compound, contains a mixture of cations and anions which are arranged in a crystal lattice, which is apparently what's drawn here by Cameron. This immobility results in a lack of pathway for the electricity to flow. When the table salt is mixed into water, thus becoming an aqueous solution, Na and Cl ions are discharged. The ions which are oppositely charged become attracted to the electrode with opposite charge. The moving charge is produced by the attraction between the electrodes, and the ions creates an electromic current which is conducted through the solution in the beaker to light up the lamp. Water is not capable of this because it is a covalent compound and does not exist as ions, therefore won't be an attraction for the electrodes, and the electrical charge won't get carried through the substance to the other electrode.
Yeah. Sure?